Properties of logarithms, day 2. We're going to continue with what we talked about yesterday as far as expanding and condensing. Today you're going to see more complicated problems, but they're still going to be solved the exact same way, and we'll see solving at the bottom of this as well, which will include some of those properties of logs on your notes page of your foldable out in front, talking about what happens to two logs that are identical to each other. Alright, in this one we are going to expand, and we've got to recognize there's an exponent on the first term and the last term of the argument. So that means we'll begin with 3 log base 9 of x. And recognize that multiplication is at work here, so we will be using the product property, 2x plus 1. And then finally 3 times log base 9 of 3x minus 1. Question number 2. We've got log base 10. Remember, if it's not written, it's base 10. So that's going to be 3 log base 10 of f plus 4 log base 10 of x minus 1/3 log base 10 of y. Now remember, order of operations dictates that we do the solution from left to right, which is why it is unnecessary in this case to have the parentheses around your two terms. However, if you feel more comfortable with that, you can put parentheses around it, which helps indicate that both the f and the x are in the numerator of the fraction. Alright, in question number 3 we'll be condensing. So we've got a pretty complicated network of variables and exponents here, so let's just see how this is working out. So when we're condensing, we're going to move all of these things back together by using appropriate properties of logarithms. So we'll start with log base b. Since they all have the same base, we do not have to write multiple numbers here. The first thing I'm going to do is draw my fraction bar, and I'm going to go ahead and place all this into that fraction. So we've got x y squared times x squared divided by y squared. Okay? Now the reason I write it like this is because now what I can do is I can cancel those two y squareds and combine these x's. Okay? And then over here I've got 3 so that becomes my exponent here. And now I'm going to simplify it one more time. Log base b of x to the third over y to the third x squared. Remember your properties of exponents. Distribute that into both of those terms, and the 3 cancels with this 3 on the x, leaving only 2. The final step is to simplify my exponents. Log base b of x divided by y to the third power is my final simplified answer. Over here, again, looking complicated, but it actually simplifies into something very simple. So we're going to move this back to the exponent. We're going to move that back to its exponent of that argument, and that goes back to this exponent of that argument, and this goes back on that exponent. The base of each of the 4 logs are the same, so it is unnecessary to write more than one log, so it's log base 4. Okay, now let's see what's happening here. Between the 125 and the x will be multiplication. So that's 125 to the 2/3 power multiplied by x squared. Between the x and the y, again, is multiplication, so that's going to be y to the third power. The next thing is division, so I'll be writing my division of 25 to the 1/2 power. Now let's simplify our numbers. 25 to the 2/3 power, 125 to the 2/3 power is 25, so it's log base 4 of 25x squared y to the 3rd divided by 5. The 5 and the 25 cancel out, and my final simplified answer is log base 4 of 5x squared y to the 3rd. Question number 5 through 10 will involve solving. Now remember, once you condense your logs, if the log on the left side of the equation is the same as the log on the right side of the equation, they can drop off. Just like properties of exponents, if the bases are the same, they cancel out, and what's left, your arguments, are how you solve your problem. So I'm using the product property, so that's going to be log base 3 of 14 equals log base 3 of x. Because the bases are the same, the logs drop off. The answer is what's left, x equals 14. Use my power property here, log base 5 of m equals log base 5 of 125 to the 1/3 power. The bases are the same, the logs drop off. What's left is my answer, m equals 5. Alright, this is the product property, log base 9 of 5 x plus 1 equals log base 9 of 6x. My logs are the same, they drop off. I'm going to go ahead and distribute the 5 throughout. And now I'm going to solve for x. Over here, I'm going to use the quotient property. Log base 5 of 42 divided by 6, which is 7, equals log base 5 of x. So drop your logs, and 7 equals x is your solution. Finally, question number 9 and question number 10. Question number 9, we're going to go ahead and solve in 2 separate steps. I'm going to begin by condensing the first part of the equation, and then I will condense the second part. So log base 6 of 48 divided by 16/5 is where I'll begin. 16/5, 48 divided by 16/5 is 15. So I'm going to rewrite this as log base 6 of 15 plus log base 6 of 5. Now I'm going to continue on by condensing one more time. So I get log base 6 of 15 times 5 equals log base 6 of 5x. The logs are the same, so I'm going to drop them off, and I get 15 times 5 equals 5x. Divide both sides by 5, cancel out your 5's, x equals 15 is your resulting answer. And finally, question number 10. Log base a of x equals log base a of 9 to the 3/2 power times 2. Log base a of x equals 27 times 2. Sorry. Log base a of 27 times 2, which is 54. Your bases are the same. They drop off. X equals 54 is your answer.